right, welcome everyone. It's so good to be here. Super excited to be talking about CodeQL here. And so just first off, why are we even talking about CodeQL and what's like the bigger context here and what are we doing at GitHub to make tools like that? I want to like zoom out a little bit and give you like the big picture first before we like do the real deep dive into CodeQL. So a couple of years ago, and like you've seen it all on the news, there are a lot of incidents happening these days in the software ecosystem, from supply chain attacks to vulnerabilities that are used to attack big corporations, small corporations. And so a couple of years ago, I think 2 years ago it's now, GitHub founded the GitHub Security Lab, which is a place where a lot of very smart security engineers and smart security researchers came together at GitHub to figure out what can we do about all of this? Can we help the larger ecosystem to make software and supply chain more secure? And how can we do that together? And so as part of that, the GitHub Security Lab was founded, which is a group within GitHub that solely focuses on, or their mission is to inspire and enable the community to secure the open source software we all depend on. Because like every one of us has projects that depend on certain open source components that you want or other way, be it directly or transitively. And so it's super important for us at GitHub to ensure that all those components are secure, that we all work together to secure that ecosystem. And so the Security Lab is a team in itself, and they use the tools that we also build at GitHub itself. And so this is where I come into the play. I'm a software engineer at GitHub. I'm working specifically on the CodeQL frameworks and support for Java. So my background is hugely, or a lot of, like I have a huge Java background, working on Eclipse as a committer. I used to work on Gradle for quite a while. I am a Java champion and now joined the ranks of GitHub to do the next step to help the JVM ecosystem. And for the bigger picture of how we treat security at GitHub, in the sense of how we help the community to do that, there are like 4 large pillars, and I'll quickly go into some of them, and then we do the deep dive into CodeQL. And so the first very important part of security at GitHub is our secret scanning component. So whenever you use GitHub to host your repositories, to commit things, to push your commits upstream, there's a service running in the background that scans for secrets in your code. So you might have accidentally left your API key in there, or some passwords, or something like that. And so GitHub proactively scans the commits to figure out, is there an API token maybe exposed and leaked? And depending on your settings, it might actually just show up on your security tab. It's like if you're an owner of a GitHub repository, you see those security tabs, it warns you about like a detected secret or a leaked secret. And either it just reports it to you, or it actually can automatically invalidate the token with the provider. So that's super helpful, because all of us, like, it happened to all of us that we accidentally committed something that we didn't intend to commit. And the thing is, even if you remove it in the next commit, it's still there in that one commit that you might have pushed. So that's one way how we help the community to secure like those endpoints from leaked secrets. Another large undertaking we've been doing in the last year or so is to host the security advisories and to enable all the projects on GitHub to report their own vulnerabilities. So if you're a project and you have some consumers and somebody, for example, finds a security vulnerability in your library, you can actually, like, GitHub helps you to submit the right CV for it. It assigns the CV ID. You essentially tell it which package is affected, which version is affected, which version actually patches the problems in those libraries. And that helps the ecosystem to keep track of all the things that are happening, and it actually allows us to feed that information into the next step, which is supply chain security. Which, when you talk about security, it's on very different scales. Like, you go from the like one line API token that you leaked over to like scanning your code, over to like the whole supply chain. How is everything built together? How are all the dependencies managed? And so, for example, I think a lot of you might have seen this already. Products like Dependabot on GitHub help you to not only scan your projects for security issues and help you to identify, like, for example, vulnerable dependencies. It also help you to upgrade them to the next versions, or to a version that is known to have those problems fixed. And so that wraps up like the surrounding ecosystem, how we try to help the open source ecosystem to secure all of that. And now let's go to specifically code scanning and what it does, how it's integrated into GitHub, how you can make use of that in the one or the other way. And I would like to first go into a very small demo. So what you got here is, it's a little repository of mine. I created it last year. It's called the JUnit 5 Christmas decoration. And so given that Christmas is coming up pretty soon, this became relevant again. It's just a little JUnit 5 extension to decorate all your tests with nice little Christmas decorations in case you feel Christmassy. And so given this is such an important part of the JVM ecosystem, I have to ensure that it's safe and secure to use. And so what I can do on GitHub is, given I'm the owner, I see that security tab over there. So I can go there. I can set up different things, from security policies, how users can report any problems with this, like in a secret manner. I have Dependabot active. And now what I want to do is I want to enable code scanning, which helps me to find any vulnerabilities I have in my project or other problems. And if I go to code scanning, so this is what GitHub offers as like the entry point for users like you to use on your projects. And then on the other side, you have all those different implementations, how code scanning can be implemented. And so, for example, on the top here, we have CodeQL analysis, which is the one we at GitHub built ourselves, or the former company called SAML, which got acquired by GitHub, built mostly, and now is integrated into GitHub. So this is the one we will be talking about a lot today. There are also other code scanning services available in the marketplace that you can like set up as easily as CodeQL. I think we covered a lot of them that most of you know, so you can just go through the list and see if there's anything that you already use and maybe you want to integrate with GitHub itself. But for now, we can, let's go and set up CodeQL. And so what it does, if you say set up CodeQL, it actually creates a GitHub action to run the whole analysis and report it back to GitHub. And we will see in a second how the reporting back, how that looks like. And so here you can configure it the way you want it, whether you want to run it on push from certain branches, on all branches, whether you want it on the schedule, whether you want to have the feedback on pull requests, like whenever you open the pull request, you get the feedback about problems there. You can say which languages you actually want to analyze. So for example, CodeQL supports a huge array of different languages. We'll focus on Java today, obviously, but if you have like polyglot repositories, then this is for you. And the rest is really just boilerplate. Like, it sets up CodeQL, it does the scanning, and it reports it back to GitHub. So if you just commit this GitHub action, everything will just work. So we'll go over to some of the results of such a scan. So here I have my JDD demo project, which has some source code that's actually vulnerable because in the JUnit extension I didn't have any problems, so I have to create some. So in this project we have a vulnerability in code scanning. It actually ran yesterday. And it found something. It actually found a critical issue. And so this is also, you see all of that in the security tab under code scanning alerts. And if I navigate there, it says some uncontrolled command line. It actually assigned the CVEs to that are CWEs to that. CVE is like the single vulnerability in a specific project, and the CWE is like the more general, like this is how projects can be affected by certain attacks. And we see here that our critical vulnerability that we introduced is we have a servlet and it's executing some commands, and it actually passes some parameters that we get from like a request into that. And so that means that anyone who has access to that API can actually pass stuff into our command execution there, and we don't do any validation or sanitization. So that's no good, because that's very easy to exploit, and we shouldn't do that. And so also you have like some history of when it was first detected, which commit introduced those things, in which branches those problems are. And so you have full visibility into what's going on. And so this is like the end user point of view. This is how you see vulnerabilities or problems that have been found by those engines, specifically CodeQL in this case. So let's go a little bit deeper into the rabbit hole and see how's that done. And as an example, I would like to use the research done by one of our people in the research lab. It's Alvaro, and he recently found several remote command execution vulnerabilities in Apache Double. And he was so nice to not only find them, reported them to the project before doing anything else, and they fixed all of them before he published any of that. But he was so nice to do a write-up of all the things he found, how he found those vulnerabilities, and how he got to the point to how he used CodeQL to do so. And so it's really interesting, because a lot of times, once you know like a vulnerability, it's like easy to look at it and say, oh yeah, it's obvious that if you pass in something here, and it's easy to exploit this. But it's only easy once you know how it's done. If you have a large code base of like a few million lines of code, there are a lot of attack vectors, but you have to find the ones that are actually exploitable. And that's really, really hard. And so in his blog post, he went through the journey. I can highly recommend reading that. He went through the journey of how he looked at like the overall architecture of Apache Dabo and went into the nitty-gritty details. And it's actually funny, because I tried to screenshot the post and it ended up being a lot longer than I expected. And so this is like, this is just to showcase like how much it takes to have to find a vulnerability and actually pinpoint it to a specific, for example, a specific input or request you do in order to exploit it. And without proper help of tooling, this is kind of impossible. And so that's actually also part of his conclusion, is how he used CodeQL to analyze Apache Dabo for potential problems or potential attack vectors that he then further tried to exploit. And the neat thing about CodeQL is, what we will learn later, is once we found one instance of such a problem, we can actually generalize it to find even more of those problems. And so that's also something that happened quite recently that made a lot of people proud at GitHub working on CodeQL. One engineer found a vulnerability in the Linux kernel, which was kind of easy to spot once you know what you're looking for. And he found one, and he went off and wrote a CodeQL query about it to detect like similar problems. And he actually found, I think, 12 or 14 other instances of the same problem across the Linux kernel. And so it was super easy to patch, but you have to know it, and you have to have the tools at your hand to query a code base to find all the other instances as well. So let's talk about CodeQL specifically. What is it? What does it do? And how can we make use of that? The first part is to think about it is CodeQL lets you query your code as thought with data. So think of it as something that lets you query whatever you're looking for in your code base. It lets you query that in the one or other way. You can treat your code base not as code, but as data. And by the way, there's actually a very nice piece by Kevin Henney on his blog about the difference between code and data that I can highly recommend reading. I can share that link later on. And so for CodeQL, what it does is it looks at your code base and it tries to extract as many things as possible in the first go. So it tries to analyze all the code you wrote, like the abstract syntax tree, the AST. It tries to look into all of that, which types are available, which methods are called, which classes you implement, which superclasses you implement, all those kind of things that also your IDE is usually doing. Another step is understanding semantics and the control flow graph. So it tries to understand not only that there's an if statement, but also whether you can reach that if statement, whether the preconditions are right to reach that or not. Is it that code or not? Is it under which circumstances can you reach certain code? Like some code is only reachable if, I don't know, the string equals foo and not bar. And so those kind of things are important to capture because they will make our query, like the life of someone who writes queries in the end, a lot easier. And so the last part of CodeQL is actually a query language. It's a declarative language which uses a couple of object-oriented concepts in order to make queries easier to reuse and to modularize, which we will also look into in a bit. And so that helps you to write queries in a more natural fashion because querying an AST is already pretty meta for most of us. So it tries to do that in a way that is easy to grasp and easy to also to build on top of other things. So with that said, I would like to start with the first basics of how to write CodeQL queries. By the way, always feel free to post questions to the chat. We will take them on later on and answer all of them. Also, feel free to, to ask them now and we will get back to them later. All right, our first example. On the right side, we have a simple Java class called demo1. It has a couple of methods. It has a greet method, which itself calls a say hello and say world, which in turn print those messages to the command line. And that's our first example that we want to query. And we start very easy. We start with a simple query that is in the form usually from where we say what we're looking for. If it gets more complex, we have a where clause to define exactly what we're looking for. And we have a select clause that tells us what is part of the result, like what do we want to see at the end. And so this very simple query from method m, method means any method definitions that we have in our system. And we call them, we introduce them as a variable m, and we actually want to select them. And so what CodeQL does when you run that query against that code base, it will actually tell you, these are the 4 methods I can find in this code base. It's great. That's not very helpful yet, but it's a query that does something. So let's go a little bit further. So this is the same query, just a little bit more boilerplate around it. So the first line is simply says import Java. It means import the Java ecosystem, like import what CodeQL knows about Java, how its types are defined, how the AST works, how data flow works, and all of that. So CodeQL can reason about it. Given this is a Java example, we will use the Java libraries that CodeQL offers. And again, we have our from where select, and the where clause now has a predicate in there. which says, give me all the methods where the number of parameters is greater than 0. And if we look, that actually only matches one method, the same method, because that's the only one that has a parameter. So now we have talked about method definitions. Now we can look for methods. Great. How about the other side? So right now we have looked at the definitions, but let's also look at who's calling those methods. And so we go back and have a very simple query, but this time we are not looking for methods, but we look for method accesses. So a method access is essentially a call site to a method. Everybody who, like every expression that is calling a method will be selected using a method access. So you always have to think about which side are you on. Are you looking for something that defines methods or something that calls specific methods? Which can be confusing from time to time, because you tend to blur the lines here and there when you try to analyze larger code bases. So once we have now have selected all our methods, let's be a little bit more specific. Let's select all methods that have more than one argument. And for some of you might say, but we just did the same thing. What we did in the previous example was we selected all methods that had more than 0 parameters. Now we select all the method calls that have more than one argument. An argument is the explicit thing that we pass in as a parameter. So if we look at that, the word clause says get num arguments. So every call that has more than one argument. And we not only select the method, but we select the first argument for that method call, which means it's say, because say has one argument, and the first argument is actually the string world. So we're not even selecting the method access anymore. We just select the parameter that is passed in. And that can be a string, that can be a variable. And what we can do with that, we will see in a second. Oh, actually, see, I forgot one. It's so easy to miss all those little methods that call here and there. I think that's also the beauty of CodeQL. It's like, it lets you query a code base and it doesn't let you down. It actually finds the places that you might be missing. Happens to me quite a lot. Oh, actually, there's one more. All right, let's go into the demo flow here. Do the same thing, but this time for real. So just for some context, the editor of choice we use is VS Code. That doesn't mean you have to use VS Code, but it's the most convenient to develop CodeQL queries. It does have like a CodeQL extension over here. You can install that from the VS Code marketplace. It lets you write queries. You have content assist, you have syntax highlighting, you have all of that. It helps you to run the queries and do all of those good things. So let's start with our first example. I will switch over to the QL perspective here. And we have already set up a few databases here where CodeQL analyzed code beforehand, and now we actually write queries to query the data in there. We will use our example database here with some very small code. We'll later on go with some queries that query Apache Commons.io and Guava, but let's start easy. So from our first example, let's do the same thing. Let's select all the methods. And actually, let's do that. Let's just select all the methods. And so, by the way, the key binding I just pressed is just running the query. So you can always go and run the query yourself. I'm just used to the key bindings. So now we selected all the methods. And as I said, it selects all the methods. Not only maybe the ones that we implement, because we only have one class with 2 methods, it also finds all the other methods from external dependencies, from the JDK, and that's not what we are interested in right now. So let's restrict it down to only the methods that are available in our source code. Like, let's not talk about third-party dependencies at this point. So we can say only methods that are from source. So this is a predicate. It means we filter down to only the things that we want to see. Let's run the query again. And we're down to 2 results. Great. These are actually the results that we have here. So if we click here, actually goes to our code, it says, okay, I found a method called greet. I call the method called translate. Let's not look into detail of what those methods do. We will do that later. So, okay, we now have found 2 methods. Now, just to get an overview of the code base and how large it is and how complex, let's select some other thing. Let's select the number of parameters as well. So our select class can now have multiple things, and they will translate over to columns over here. And so if we just run this, we will see in the first column, we have our method. And the second column is the number of parameters we just did. You can also give them nice names, pretty similar to SQL. We use as, and you can give it a name. So the result is kind of readable. And so this is for developing queries in VS Code. This is also for example, checking out the code base. You can also put them on or push them on GitHub and run them as part of your CI job. That's completely up to you and what your needs are. For now, we will just look at the results here in the CodeQL query results viewer within VS Code. All right, so let's take another step and say we want to not only get the number of parameters, we also want to filter down to the methods that have a certain amount of parameters. We can now quickly do like an AND, I don't know, where it equals 1. Or, and this is actually the fun part about CodeQL, you can also refactor this, because in the from clause, you can always say, look at all the things that are a method, or look at all the things that are a string or an integer, and then you can filter it down. So we can actually say, look at all integers that are all possible integers, but only look at the ones that are the same as number of parameters, and at the same time, that are 2, and then select those. And so this might at first seem a little bit counterintuitive, and it might actually be for this small example, but it's actually quite interesting, this concept of filtering it down from various angles, because CodeQL will now try to figure out what are the possible integers that match both those conditions. Both they match this one, and implicitly that also means it only matches methods that match this one. And so if we say that, it actually gets the method that has 2 parameters. All right. That's with that. Let's go and continue here. So the next step is, it's great. Now we find like syntactic elements in our program. We can find if statements, we can find methods, we can find method definitions, parameters, strings. We can find all of that, right? But that doesn't help us to really understand the semantics of codebase and, for example, how data flows between different parts of the system. And especially for vulnerabilities, that's actually the interesting part. How does data get from A to B, and where can it actually attack or exploit the system? And in order to understand it, I want to introduce some very basic concepts, at least their names, so we all talk about the same thing. The first concept is the source, which is any place in the program or in our system that where data comes in from the outside, for example. The other part of the data flow analysis is a sink, which is a point in the system where data flows into and can cause problems or havoc or something else. And the trick is that not every source and not every sink are problems. It's specific sources that flow into specific sinks. That's the problem. So in this case, we use XKCD's Bobby Tables example. It's a regular SQL injection attack. You have a request parameter, which is our source, and a request parameter in itself is not a problem. It becomes a problem if you have, like for example, SQL injection or like an escaping character in here, and this actually flows into a sink that runs a SQL query. Only the combination of the two, the SQL statement and executing that SQL, the combination of that is a problem. And let's see how we can figure that out from a CodeQL perspective and what intricacies are given there. If we look at the right, we have another small program. You've seen it in VS Code right before. It's a greet method. It takes a string, and on one branch, it like in the if statement, it does something with the string, and the other one, it just returns the string again. On the left side, on the top, you have some imports. You can ignore them for now. On the bottom, we have our CodeQL query, and we'll go through that one by one. We will look at a source and a sink, and you can see I defined them as path nodes. And if we remember our from clause, it looks at all the things. So it looks at all things that can be a source, all possible things. It can be any expression in the program, can be any parameter. And we look at all the sinks in the program, every node that's possible. It can be any expression, anything in the program. So we're essentially right now, we're saying, give us all things in the program and look at all things in the program and try to combine them and see where we can see some flow from A to B. And because that is a problem that's not solvable, we have to restrict it down to something that makes more sense. So for that, we have the configuration. And let's look at the configuration. The first part, what we do here is, given we don't want to analyze like everything right now, at least for this demo example, we will restrict it down to a specific method. And in this case, it's our greet method. And what we do here is, in previous examples, we've used the where clause. In this example, we use a class, which is another way of representing something or the same filter or the same precondition. And we say our greet method is a callable, which is either a method or a constructor. And it has to have the name greet. So it matches any method in the system that is called greet. And hopefully it's just the one there on the right. If not, we have to be more specific. But for that, that's okay. We match only that. The next step is to configure which data flows we are interested in. And for that, we introduce such a configuration. As you can see, it extends data flow configuration. So we talk about data flow from flowing from A to B. And it first defines a source, which has to be a parameter. And at the same time, it should only be the node getting closing callable means it has to be, that parameter has to be in the greet method or in the method here that we filter on. So this means that we only look at exactly those two parameters for now, just for the sake of following the example. Okay, now these are all our possible sources. Let's look at all the possible sinks. If we implement it right now, we can say we want to look at all the sinks that are a return statement. So from all the return statements in the program, we only look at return statements that are in our greet method, and all the sinks that we are interested in should be part of that return statement, which gives us the return statement on the right, which is that one. The careful listener might have realized, but Benny, there is one more return statement 2 lines above. What about that? And that's actually a very good question. What about it? So we've now established that we have our sources flowing to our sinks, but what about the other one? And for that, we need to look at the translate method, what it does. And if we look at the translate method, it takes the string that we've seen before, and it does a lot of processing with it. It wraps it in lists and iterators and extracts the bytes and actually creates a new string. And it's not a string anymore. It's something completely different. You as an engineer, you look at it and say, that's still the same. Like the attack vector is still the same, but you have to first recognize that. And for that, CodeQL offers something really nice. Most of you might have not seen it on the left side. In our query, we don't extend data flow configuration anymore. We now extend taint tracking configuration now. And that means we not only track raw data flow, but also if one variable taints another variable or it poisons it. So if I have a string and I turn it into some other data structure and maybe turn it into a string again, it's still the same string, or at least part of it, and it can still be dangerous. So with taint tracking, we can follow that. And so with that in place, with the taint tracking, we actually recognize translate, returns bar, maybe in a different form, but it's still dangerous. And so we have the two flows. All right, that was a lot. Let's look at it in action. So we have our regular flow, as we've discussed in the first example. We have a flow from source to sink. Like in our example, the flow was from a parameter to a return statement, very simple one. But in any real application, you also have not so easy to follow flows. For example, you have a lot of frameworks that do some serialization or reflection or other things that you can easily lose that data is flowing from A to B because of all the interactions in there and all the things that you can't follow. So for that, CodeQL has a concept of additional taint steps, where CodeQL authors and engineers work on supporting the various frameworks, and for all the flows that are not easily detectable, actually helps the engine to overcome that gap. So for example, in Spring or in other libraries, we help to say, okay, if data flows into here, it might come out of this other method, so we can like keep track of the whole flow. Same goes the other direction. Sometimes we have flow like data from one side, it goes through validation and flows into a sink. And at that point, it's like, yeah, but this is not a problem. Like we've validated the data. It's not poisoned anymore. It's not tainted anymore. It's safe to use in a SQL statement. So we have to ensure that these are barriers, certain validation methods that help us to stop the flows. Otherwise, we have false positives in our queries. And with that, let's go to the next example. So this is our example from before, our greet method, sources, sinks, and let's just run this and see what happens, just so you can see it in action as well. So our query here has found two data flows. If we look at the first one, these are all the steps how the data flows. So it tells you data flows from bar to the return statement. And for example, if you find, like, if you set up those queries on GitHub, it will actually, as part of the reporting, will tell you where the data flows through, like through which method, where it originated, where the sink is. And so this is our easy flow. And now with the taint tracking enabled, we also see the data flow, which we discussed. Like the parameter is turned, like it goes into the translate method. It's a parameter here. It is wrapped in a singleton list. So we keep track of this list now contains some tainted data. It flows into an iterator. And with the next call, we actually pull it out again. So we keep track of that. It returns, like it extracts the individual bytes. So this is just a byte array, but we still know like this was our original string. And so when constructing that, we actually still realize, okay, with taint tracking enabled, we know this is still the same data, or at least part of the same data. So it can still it still needs to be treated as tainted unless we have some validation steps in there. And so we know this is another sink where this data flows to. And now we've only looked at like one single method right now, but the same query can run through like your whole system, and whether it crosses like one method or 10 methods or 100 methods doesn't make a difference for the query. It might run longer, but the query itself is the same. All right, and we, yeah, that's that part. I would like to quickly play around with one other thing, and that is, if you look at our configuration, we've done a very basic thing. We said as a source, we want to look at all the parameters, and that's very generic. And so in real queries, what we do is we already build, like at CodeQL, we have a library of little building blocks that you can use to write new queries. And so, for example, a common source that a lot of queries use is some remote data. So any data that comes in from the outside, that's usually a good starting point for finding attack vectors. And so that's one thing we have here that's ready, available in the CodeQL code base. It's called a remote flow source. And as you learned, this is just a node, and we have different types of implementations for that all know about like certain frameworks and how they can be detected, and that can be sources of tainted remote data. So for example, certain RMI methods are sources of remote data, JAX Web Services, JAX-RS, reverse DNS. I think this is also JAX Web Services, Play, Spring, Juice, like, and you can also contribute them from the outside. So whenever you want to know where data enters the system, this is actually a good starting point. And so let's just run this on a code base like Apache Commons IO, and let's see what happens. So what we do is we select all remote flow sources, and we select in which type they occur, in which method they occur, and the source of the remote flow. And for example, in here you see Apache Commons has a few of them, which is generally, like, this is not a problem. It's just, these are places where remote data can enter the system, and we have to treat them accordingly. So for example, in their XML stream reader constructor, there's a get input stream call from a connection. So this is, for example, where we have to look at, is this data valid? Is this what we expect it to be? Because this is like one angle an attacker can start an attack. All right. Let's wrap up the data flow part of this discussion, and coming back to Apache Double. So the way the security labs team did that was they looked at Apache Double with some of those CodeQL queries and tried to figure out what are good sources, like what are good attack vectors. And so they found like some codec that helped us to help them to find those steps that are actually like ending up in a sink that instantiates objects without any validation. And using that, they actually found several CVEs with one simple query, because it was not only a single instance, but multiple instances of such problems. And that brings me to an end. I've listed on the left, I've listed some resources, how to learn CodeQL, how to set it up for your own repository, how to write your own queries. There's also like an awesome workshop there, finding security vulnerabilities with CodeQL. I can highly recommend that. And you're always free to come to the CodeQL open source repository, help us improve those queries, and help us improve our security world software together. Thanks so much. I'm happy to take any questions at this point, and I'm giving it back to the studio.